In this example, we're given two parallel lines and a triangle is being formed here. So it's given that L is parallel to M, these two lines. AB bisects angle DAC. So bisects means that it's going to form two equal angles as a result, congruent angles. CB bisects ACE angle, right? So this angle ACE is bisected into equal congruent angles. So now we have to prove based on these given statements that the measure of angle B is 90 degrees, right? So the measure of this angle is to be proven that it's 90 degrees. So the first thing we do, we provide the given statement. So everything that's given we write in the first statement, and then we justify it as given being the reason for it. Okay, so now the second statement immediately follows that angles DAC and ACE are consecutive interior angles. Now let's take a look at that. So DAC, so this angle, this whole angle, and ACE are consecutive interior angles, right? So basically they do not occupy the same position. They're not going to be equal in length unless they're both are equal to 90 degrees. But usually they're not, right? But they're consecutive. Basically you can think of them as two angles that are inside, okay? That are basically defined by the transversal and two parallel lines. Okay, so they're inside and they're called consecutive interior angles. And the definition, the reason for that is simply the definition. The definition of consecutive interior angles. Now the next statement follows that these two angles DAC and ACE are supplementary. Supplementary basically means that the sum of the measures of these two angles will be 90 degrees. And that's based on the fact that these two lines are parallel, L and M. And when you have a transversal, you will have consecutive interior angles that will be supplementary. Now, so the reason for this will be simply lines N, well, L and M are parallel. Okay? So if these two lines were not parallel, then obviously these two angle measures when added would not necessarily be equal, would not at all be equal to 90 degrees, right? So only when these two are parallel and you have a transversal, these two consecutive interior angles are supplementary. Okay, so now that we know that they're supplementary, we can go ahead and say that the measure of DAC plus the measure of angle ACE is equal to 180 degrees. Okay, so the reason for that is going to be the definition of supplementary angles. Right, because as we just discussed, supplementary means the sum of the measures is equal to 90 degrees of any two angles in question. So now the next part is to see from the given statements that measure, well, first let's say that angle BAC is congruent to angle BAD, and also angle ACB is congruent to angle BCE. Okay, and let's take a look at that before we explain it. So BAC, this one, is equal to BAD. So you might have guessed, how do we know that? We know that from the given statement that AB bisects angle DAC, right? Because it forms two congruent angles as a result, which are these two. And this one, ACB and BCE, these two are congruent for the same reason, because BC or CB, however you want to say it, bisects angle ACE. Right? So these statements come from the given information. Okay? Just as the previous statements were. Right? So the reason for that will be the definition of an angle bisector. Okay? Because we know that these two are angle bisectors, these two lines, and they form congruent, two pairs of congruent angles as a result. The next statement is going to be that the measure of BAC is equal to the measure of BAD, and the measure of ACB is equal to the measure of BCE. Okay, and the reason for this is going to be the definition of congruent angles. And the reason being is that when you have two congruent angles, their measures will be equal. Now the next statement will say we will use the angle addition postulate. So take a look at this angle ACE. ACE can be expressed as the sum of these two that are congruent, right? So we can express it as a sum. So the measure of ACE is equal to the measure of ACB plus measure of BCE. Okay, let me write that a little better. And the measure of angle DAC can be expressed as a sum. So where's DAC? This one, right? So we can express it as a sum of two congruent angles, right? We can express it as the sum of these two. So so we can say BAC. So let's see, right, so BAC plus BAD. BAC plus measure of BAD. Okay? And the simple reason for that is the fact that, again, it's just the angle addition postulate. Angle addition postulate. Now the next statement, notice that we can use substitution property. So notice that we can say measure of ACE is equal to measure of ACB plus ACB. Okay, now how did I know that? Notice that I substituted the BCE here with ACB. And how did I know these two were equal? Based on line 6. Remember we said these two equal based on what we found in statement 5? So I just substituted BCE with ACB based on this equation. Right? This is called a substitution. And the same thing we're going to do here. For the DAC, we're going to say measure of BAC plus itself. Plus BAC. And how do I know that? I use this substitution right here using this equation. Right? So BAD was equal to BAC, so I just substituted the BAD with BAC. Okay, so this is the substitution property of equality. Now the next statement, notice that we can use substitution again because we have to simplify these two, right? We have to simplify. So measure of ACE is equal to twice measure of ACB, and the measure of DAC is equal to the twice of the measure BAC. right? And this is a substitution, right? Because when you add these two, they're the same measures, you get twice each measure. When you add these two BACs, they're the same measure, you get twice each measure, right? This is simple algebra. Okay, so and again, this is substitution, right? You're substituting this expression for simpler one-term expression in each case, in each equation, right? So this is the substitution property, and I'm going to use quotation marks because it's the same reason as line 8. Substitution property of equality. Now the next one, we're going to use substitution property one more time. Notice that measure of ACE is equal to this now, the twice of measure ACB. Now let's find measure of ACB. Remember that measure of ACB was equal to measure of BCE. Okay, and also notice now that this, we can use this line right here, this equation, and substitute each of these measures of these angles with respective terms, right? Because measure of ACE is listed as twice the measure of ACB, and measure of DAC is listed as twice the measure of BAC, right? So let's substitute that, right? So the reason for this will be, of course, the same, but let's write it down. So using this equation and rewriting it on line 4, we're going to get what? We're going to get twice the measure of BAC plus, now again, this is equal to measure of DAC. That's the first term in line 4 equation. Now measure of ACE is twice the measure of ACB, and this is equal to 180 degrees, right? And again, this is substitution property of equality, right? So the same reason as in the lines before. Now it's going to be simplification, and yet we're going to call it substitution. Well, not substitution, but we're going to divide, right? We're going to divide both sides by 2. Okay, so dividing both sides by 2, we're going to get this, twice the measure of BAC, right, plus twice the measure of ACB is equal to 180 degrees. If you divide both sides, you will get something like this, right? And we will call that the division property of equality, right? You're dividing both sides. Now if you simplify that, you're going to get this, measure of BAC plus measure of ACB is 90 degrees, right? Because 180 divided by 2 is 90, right? So this is simply the substitution property of equality Now where do we go from there? Notice, let's find this graphically. So measure of BAC is this one, this angle, and measure of ACB is this angle. So great, we already found that the sum of these two angles in this triangle, in triangle ABC, is equal to 90 degrees. But we need to show that the third angle measure, precisely measure of angle B, is 90 degrees. So we're getting there, right? We need to work with this triangle. So in this triangle, the sum of all interior angles is 180 degrees. So we can say that the measure of ACB plus measure of BAC plus measure of angle B is equal to 180 degrees, right? Because the sum of the interior angles in the triangle is 180 degrees. You can also write a step before this saying that ABC is a triangle if you want, and provide reason as definition of a triangle, but that may not be necessary because it's obvious that this is a triangle. So you know, you can skip that step and directly go to the sum formula for the interior angles, right? So ACB, BAC, and measure of angle B is 180 degrees, and this is the what? This is going to be simply the definition of interior angles of a triangle. Right? Basically, when you try to find the definition of interior angles, you will know that the sum of all interior angles in a triangle is equal to 180 degrees. This is what the definition is. So now the next one is obviously to substitute, right? Because line 12 gave us the sum of the first two, right? These two. They're written in different order, but addition is commutative, so you don't have to worry about that, right? We know that the well, if you want to be really careful, if you don't want to, you know, write a line for commutative property, you might as well just copy it directly like this in the order that was written on line 12. You can say BAC first and then write ACB first, just to be sure that you don't have to use commutative property, then give the explanation for that, etc. Right, so in any case, now you can use direct substitution. So you can say that 90 degrees plus measure of angle B is equal to 180 degrees. Right, and this is simply the substitution property of equality. Substitution property of equality. And now finally, you're going to subtract on both sides, right? So you're going to do 90 degrees plus measure of angle B minus 90 degrees is equal to 180 degrees minus 90 degrees, right? You're subtracting 90 from both sides, so obviously this is going to be subtraction property of equality. And now finally, this statement, the last statement, as you should see, is going to be the substitution. 90 minus 90 is 0, right? 0 plus measure of angle B is itself. So the measure of angle B is on the left side, and substituting 180 minus 90 is 90 degrees. And the reason for that is simply substitution and not subtraction. Notice it's substitution. These two words may look very similar, but be careful that you tell the difference. Substitution. And the reason why I'm saying to be careful is because if you write quotation marks, your professor or teacher is going to think you're talking about subtraction. Be careful that you write it down. It's not the same reason as line 15. Right, so substitution property of equality. Right, beautiful. So you've proved this statement that measure of angle B is 90 degrees. Hope this was helpful. Thanks for watching. See you in the next video.